Hello, everybody. So, continuing on, I guess moving on to the next little couple topics to cover. The next thing on the list is one that doesn't really fit very well in classrooms. We go over it, but ultimately it's something that is unique to every situation, and what is typically shown in the classroom and textbooks and tutorials is very, very lacking. That's exception handling. The standard example that you will almost always see in tutorials and textbooks, you put together your try-catch block, and if something goes wrong, the program stops running and spits out a message. But that's what would happen if you didn't handle the exception. So it's not really handling the exception. We'll look at the syntax for it tonight, and probably next Thursday, when we're kind of wrapping up this module and trying to work all of them into one example, I'll put together a better exception handling thing where the program doesn't crash. We might do some of that tonight. There's not a ton on the list, but yeah, we just need to see the syntax, because really we need to know what's going to happen on it. And that one's a little deceptive when we see it in class. What we look at tonight is will basically be, we might take it a step further, but basically we're going to look at the syntax for it tonight, which is going to be what textbooks and tutorials do. The part of exception handling I don't like in textbooks, where if it hits an error, it stops running and prints out a message, which is what it would do if we didn't handle the exception. But that's what we need to see to cover the syntax without a lot of extra clutter getting in the way. But really, when you get out in the real world after school and you're making software, it is not uncommon at all for your exception handling to be 3 or 4 times longer than the actual program. And hopefully that will never run. Hopefully that code will never hit. That exception is never going to happen, so that code's never going to run. But when you put your software together, you want to make sure all your bases are covered. So sometimes that can get really, really long on major projects. Much, much longer than the actual software itself, just carrying out its task. Let's see. A couple quick announcements. I was looking over one of the recent quizzes, I think module 2 quiz, and I jotted a note down. Any of the questions that are asking about Java code, make sure you run that code. There should be enough time in the quizzes, right? Or there's multiple attempts. So copy all of that code in the first attempt if the clock runs low, and then on the second attempt, you will have ran all that code and see what happens. You have time for that. This is a certification exam. On the certification exam, you'll see things like that. So you want to make sure you can read it. But for the classroom here, you do have the option of running that code when there's a question about the code to see what happens. So I thought I'd make a note. One thing about due dates, if you had not noticed yet, the midterm is due before the break. I have to turn midterm grades in for this class that following Monday, when you all will be on a week off. So I wanted to have the midterm grade done before that, because otherwise things will be, it's not a very even split between midterm grade and final grade that way. So it's a couple weeks for the module, but the midterm will be due halfway through the module. Perfectly. Actually, that's the end of the module, but the homework isn't due till we get back. The homework assignments due on the regular first day of the next module, that Tuesday when the next module starts, which isn't until after the week off. So make sure you do the midterm first. There's 2 parts. The first part is a bunch of questions like quizzes. Very, very, very much like the quizzes. It's pulling from the same question bank as the quizzes. So to study for that, you get multiple attempts at the quizzes, and it saves your best score. So keep opening the quiz, and before long you'll see every question. every question in that question bank. Or you've probably already seen a lot of them before. And then the other half is just writing a program, which the one in the statewide course shell I thought was easier than some of the homework that we've done lately. So I just left that there. So yeah, might as well make it an easy exam question. No need to trick people up now. But make sure you get that done before fall break. That is different than the other due dates. Exception handling, and file IO are the topics for tonight. Does anybody have any questions before we get started tonight? Oh, and this time of the semester, so it'll carry over into next week, because everything else is in 8-week classes, which means you have final exams and stuff. I'm gonna try to keep it short for lecture. We've got a few things to cover, but we don't need to talk for hours when I know everybody has other tests and research projects and essays and all sorts of stuff to do for all your 8-week courses or midterms if you have other 16-week courses. It's a busy time of the semester, so it probably won't be too long of a lecture tonight. Like the other IT course that's on campus is virtual tonight, so campus is very, very quiet. But our next topic is a very important one. That's going to be exception handling. Oops, that doesn't look like an O. Exception handling. First off, to deal with errors and issues that arise, errors and little hiccups that arise along the way, that's sort of an art form. Some people have into or seem to show more talent for it than others. We'll talk about some of the concepts and the syntax, but you'll want to practice that, adjusting for things that can go wrong. Like that point I mentioned beforehand, the big thing is textbooks and tutorials have to keep it short. So they just have to show the syntax. That's what we're gonna do on our first pass here. Maybe I'm currently thinking next Thursday we'll have one of those examples that work in all the concepts we've looked at in the last couple modules, and we'll see some more realistic exception handling. But it's something you want to practice and improve with time. The goal is to keep the program running no matter what. That's always your goal. So that's the problem with that with textbooks and tutorials, and well, relate to tonight's lecture over the syntax on it, is we're gonna do the same thing that would happen without exception. If there wasn't exception handling, we'll stop running, we'll stop the program and throw out a message. Probably even throw out a stack trace. The exact same thing that would happen if we didn't put any handling there. But we need to see it, and we'll see it more. We'll see an improved context for it, but it's another one of the things that's often quite big. It doesn't fit in the classroom. I keep throwing out that word exception. And well, actually I use both of them intentionally there. There's two types of things that can go wrong. There's errors and exceptions. Does anybody know the difference between them? I don't see anything popping up in the chat room. Nobody's super excited to ask. And we'll often use the terms interchangeably, but there is a technical difference. An error is there's no recovery. When an error happens, there's nothing we can do to recover our program. It's crashing regardless. An exception is a small hiccup. I'll put it that way. A small hiccup, often anticipated. something that we should have expected was going to go wrong, right? The board over here. Yeah, for example, our program spits out a prompt, enter first number, and the user's going to type in something. Then we spit out another prompt, enter second number. And the user gives us a number. And then our software internally is going to take those two numbers. Well, I'll just put them in X and Y. X equals first input. Y equals second input. And what we want to do with those is take Z is X divided by Y. There's a big problem that could happen there, right? So everybody spot that as you head out to the classroom. Because in most cases, it's okay. But if the user gives us a 0 there, that's something that's mathematically impossible to do. If we write it out like elementary school, 0 divided by something, any number, so I'll put a 3 there, some number times 3 gives us 0. We know what number that is. That's easy to do. But the other way is a problem. Some number divided by 0, or some number multiplied by 0 gives us a 3. And there's no number that would possibly work for that. So it's an error that we probably should have anticipated when we put this software together. So it's not an error because we could have anticipated that and prepared for it to happen. Is the second number a 0? If so, we need to do something else. Sort of an if-else structure. And our syntax for exception handling can kind of be used for selection structures at times. It's actually faster than a selection structure. When computers compare numbers, they subtract them. And these days, we're mostly all working on 64-bit machines. So if we subtract a number, and need to check whether it was greater, equal, or less than, we need to check all 64 bits, or the machine does. A human could glance at it and see if it's all zeros, or if the first bit is a 1 to tell if it's positive or negative. But the machine's going to read all 64 bits. But an exception can happen off the first bit. So we're saving time of processing 63 bits doing that. And that can add up when there's a lot of things. So every once in a while, you'll see some code, and Java is one of the languages people do this in, because there's very powerful exception handling. Really, really good way to handle all of our exceptions. There are actually multiple ways. So this is one of the languages it shows up in that can be used to buy back speed. The problem is when you write the way that does that, it's actually the unhandled exception is what you want to run. So if you're not the one that wrote that code, it is an awful mess trying to figure out what it's doing, because the thing that the code is actually doing is the one thing not written in the text file. So you have to go through there and figure out what all could happen, and go through the list of the exceptions that are handled and figure out which one is missing to figure out what the software is actually doing. It's much, much faster. It's quite a bit faster, but if you're not the one that wrote that code, it's an awful thing to figure out what's going on with it. But it does show up in Java sometimes. I don't know if we'll look at an example of that in class, because it is very, very confusing. Just want to make sure you all are aware that that's something we can do. Basically using our exception handling as an alternative selection structure that runs faster. Personally, I prefer to do it mostly in selection structures. I'll build big if-else structures just because of what I'm used to, and that seems to flow more naturally out of my mind for even what we're going to cover tonight. But It's an important thing. But errors and exceptions are different things. An error, there's no recovery from. That's like events completely beyond our control. And exceptions are just little issues, things we should have anticipated, division by zero, somebody asking for the fifth element in an array that only has 4 things. Those little things that might happen that we could see going wrong with our software. An error, put it in terms of an analogy here, an error is like the boat hit an iceberg and it's going down quickly. There's nothing you can do but swim. Hope you fit in a lifeboat or something. There's no recovery from that. Whereas an exception is the things on the boat are getting a little damp. It's a boat, or obviously things are going to be wet. We can anticipate that and prepare for it. Bring extra towels because we're on a boat, and so we know there's going to be water around. Versus the boat running into an iceberg and heading straight to the bottom of the ocean. There's a big difference between those types of things. And that's how errors and exceptions are used differently. What I put in my notes here: runtime errors will cause our program to crash, but we'd like it to keep going. Like in this case, the user enters a 0, we're like, oh, we can't divide by 0. Try it. Give us a different second number. Or put those in a different order. Or at best, gracefully shut down. Okay, pop up a little message box that says program encountered a problem and needs to restart. That looks like way less severe of a crash than the program just stops, right? It just disappears from the screen. It's a little alarming when that happens. It's like, what happened? Did I bump the wrong button? You can't quite figure out what happened. Or graceful shutdown, we can attempt to save the work up to that point, throw up a little message and say, we got to restart. That's exception handling. Trying to anticipate everything that could go wrong and then dealing with the situation, hopefully in such a way that the software keeps running and the user never knows something went wrong. I'm missing a page here. Notice on my next page, start in the middle of something. An exception, it passes back to the caller. We'll see that in the example. I seem to have lost a page from the notes. I'll set those down. The example is the syntax is fairly straightforward. I'll write it up here on the board. I'm going to go ahead and erase the example. That one wasn't too important, just one that hopefully everybody is familiar with. I think by this point, everybody's had a math class, right? You know, you can't divide by 0. Or problems occur if you try to divide by 0. Those who've got to calculus, or maybe it's in calculus 2, may have reached indefinites, because there's other issues that could occur, like what's 0 divided by 0? Or in terms of a fraction, 0 over 0. That's a different kind of problem altogether. Because we have several rules, and it's really hard to say which rule takes precedence. Is this a 1? Because they're the same. Is it a 0? Because the top of the fraction is a 0. Or is it undefined? Because the bottom's a 0. We can't really say anything about that number. A different type of problem altogether. But something that if we were asking for 2 numbers and dividing, we might encounter. So we would need to check that, because indefinites could be handled different. Indefinites should be handled differently than just dividing some number by 0, which we can't do. Our basic syntax, well, there's 2 ways. So when we make a method, I don't know, public and my method, that sounds like a good name for it. We can include a little statement in here that says throws. I'm putting it in a different color. That's gonna make it stand out.
throws exception. Then finish out our method like normal. I'll just put dot, 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 all the stuff that would go in there. And when we do it that way, it passes it back to the caller. So we would probably want to do that on all of our methods all the way through. You may have seen it in some of the automatically generated code already. It'll put up the method and say throws exception. And that's sending it back to the caller, because then we don't have to put exception handling all over the place in our code. We can put it in one spot. For example, we could put all of the exception handling in the main method, the try catch block there, and then every other method simply throws an exception so that it goes back to the caller, which would have been called by something else, goes back to the caller, back to the caller, back to the caller, and keeps getting thrown back. It's like, oh, this is somebody else's problem, until it gets all the way back to the main, and we put all of our exception handling in the main to keep it nice and organized. We can't really go back further than that. If we tried to throw back further than that, it would be the Java virtual machine itself. And that's probably not going to handle exceptions gracefully. But actually, y'all have probably seen it by now. That just throws out a traceback. And one rule is a good rule for exception handling is never, ever, ever let your end user see a traceback. When we're debugging our software, that's what we want to see. Right? That's the thing that tells the developer exactly what went wrong, where it went wrong, what led up to it going wrong. But y'all know what a traceback looks like. That's going to make the end user completely panic. Like, what is all this stuff? So if it goes all the way back to the Java virtual machine, like your main throws exception as well, all you're going to do is print a traceback. But basically, that's like passing it back to one spot, pass it back to the caller, and it helps us to organize our exception handling. We still have to handle the exception somewhere, but we don't have to handle exceptions everywhere when we do it that way. The other one, our keywords can be try. We looked at that before. Try, then the stuff we want to do. And we'll try to run a piece of code. Try to read from a file. But if for some reason we can't, whoops, we put the keyword catch, and then in parentheses, some sort of exception. Along with a reference to it. So exception is a type. Give it some sort of reference. I'll just put E here. And then in the block, E dot, I'm going to write fix problem. As a method. So tonight's example, we're probably just going to print out a message. That's not really fixing the problem. But, and then what I just said, we try to read from a file, and for some reason, we can't read from that file. Well, that's an easy thing to fix. Rewrite that file. Maybe it's our database. So try to save databases. Try to save your database somewhere and revert to a backup copy of it. Or an emergency worst case scenario, minimum amount of information that we need to read, and actually rewrite that whole file. Because in the process, we would have that as a string. So then we can use the string in what we actually want to do. And the next time the software runs, that file should be there because we rewrote it. That's fixing the problem. That's what we ultimately want to do, but that's what we don't really have time to do in the classroom. We're in time constraints. There's a lot of stuff we want to see. And that has to be unique to every situation. There's not a one size fits all on exception handling. It is unique to the situation. That's why I wrote exception up here on these. Exception is a class
that we can use. And we can extend it and make child classes of it to fit our own needs. So we'll probably look at that. And there's a bunch already made, which all of the ones that are available, null pointer exception, division by zero exception, index out of bounds exception, all of those are a child class of exception. So this is the catch-all one. So for classroom examples, when we're tight on time, that's probably what a try catch block would look like. Try catch exception, which would catch every possible exception that could happen. And but usually we want to be a little bit more specific. I guess there is one more word I could write up here in the example. After that, we have the keyword finally. And I'm very much out of room, so I'm just going to write finally and some dots. But the keyword finally is the code that's going to run no matter what. So rewrite that one more time. So try is what we want to happen. Catch will kick in if things go wrong. But the only time in software development I can actually use green and red properly for the notes. And finally happens no matter what. Always happens. So those three parts, and we can do lots and lots and lots of catches. Definitely don't have room for it on the board, but if we're dealing with maybe arrays and lists, we can try to catch a null pointer exception, catch an index out of bounds exception. Those are the first two spring in my mind. There's more of them, but we could try to have a long try, then a whole bunch of catches, all of them that relate to arrays and lists, then maybe a couple custom exceptions that we made ourselves because we know exactly what is happening in those arrays and lists. So we don't need to fall back to that generic catch-all situation. We know what could go wrong. And then finally, at the very bottom is the parent exception in general. So with, I guess, polymorphism, you want to work down to the most general one. Start with your most specific one and see if that's the problem. And your next catch has a slightly more general one. So going up the inheritance tree, you start with that lowest level where all the details have been worked in, and then work back up until you get to the completely general exception one at the bottom. Or just use exception for everything. The code will work that way. But let's look at some examples. Does anybody have any questions before we pull those up? Okay, I assume that means no questions. So I guess first thing to look at, I'm going to look at exception and Javadoc. Because it is a data type, so there's Javadocs about it. So I'll make sure I pull up the right one. Pulling up Java E, and this is what I wanted to look at, direct known subclasses. So they took that exception handling, which we can scroll down here and read about. Exception and subclasses are formed throwable. So they have a parent called throwable. Hence our syntax up here. We can throw stuff to so that another part of the code deals with it. Which I think is related to callbacks. Oh no, it extends objects. It's parallel to callbacks. Exception, and it handles runtime exceptions. So syntax errors do not go into exception handling.
A syntax error is going to cause, it might throw the overall exception if the computer can't figure out, if the compiler doesn't notice the typo and it makes it that far, it'll be like, okay, can't figure out what's going on, but something went wrong. But it's runtime exceptions, so not syntax or logic errors. I need to check a bunch of them. And you can see a couple constructors. Create a new one, but really that's, so when you extend it and make your own class, you can see what the constructors are. The Java virtual machine is usually the one that's going to create a new exception and give that back to you to work with. I can't think of any situations where that would apply, and I don't think I've ever actually called create new exception manually in the code. The Java virtual machine does that, but here's the ones mostly for when we extend it and customize it to fit our needs. So we don't need the general catch-all one. We know what's happening in our software. We can do better than that one size fits all. Looking for the data fields. Do they not list the data fields? Oh, you can see the main data field there is there's a string message, throwable, cause, booleans about suppression and writing stack traces. If you look through the methods, you'll see the classes, the data fields there. There's not very many of them, but they all make sense when you, like, what caused it, what sort of message should come with that. And the message there isn't a print out message. The message is going to be built into the exception and come back to us as a programmer so we can see what the message is to deal with. We can basically run that message through some if-else structures. Or suppression, ignore it altogether. One thing I've often done, I'll open Sublime, because for reading files, I will write it, I will do this. I think when we looked at it the first time, we looked at it all formally and did the, whatever the Boolean is has next. I'll just say while true, and then read file. Because eventually that's not going to be true. And it's in a try catch block. So eventually that's not going to be true. So I just grab the exception and just move on. The exception block will be blank. It may be a comment that just says just move on. So I remember that it's supposed to be blank when I look back at it 3 years later or something. But eventually reading a file will not be true. And in which case, it's in one of those situations, it's only going to need that one bit from the next line of the file, or that one bit missing when there's not a next line to the file, to throw that instead of all the processing that would take with peeking ahead and checking to see if there's next file, and there's extra stuff involved there. So this is one of those taking advantage of how it's faster. We only need that one missing bit from the next line instead of processing an entire line, like we did last time with the scanner, I think. We do scanner has next. If we didn't do that last time, that's what we're doing either tonight or Tuesday. But this is how I usually read files in Java. I know eventually it's going to be false, and it'll just kick out, hit the exception block, and there's nothing to do there, so then it just moves on with the code. And that's faster than going through a scanner object. Okay. So you can see there's a long list already made, and they're all objects. So we can, again, we don't have to go all the way back to the initial exception to extend something. If we knew there was a bad date, I see that on. Oh, it's not a date. I misread it. Invalid MIDI data. So musical interface
Musical interchange. Oh, the other way. Musical interface data interchange. Interface and interchange are the two I's. I never can remember which order they go in. I've never been able to remember that one. It slips my mind. Oh, musical interface data interchange, because it refers to like the keyboard, the human interface. I always have to think it through like that. But maybe we're getting bad data from a keyboard. There's an exception built in for that. But that's a catch-all exception. And we know what our software is doing. It's not a catch-all. We don't need to worry about every single thing. Maybe we're connected to trying to think of a keyboard. None of the names spring to my mind, but maybe we're connected to a particular classic drum machine. And all the names that are popping in my mind are old ones, like the original sense. When chord was new, like the 70s ones, which would have been before MIDI. An 808, that's a good one. Yeah, so maybe we know we're connected to an 808. So we don't need to catch every single thing that could go wrong. We know the limited number of things that could happen on there. With what's available. So we could extend that and customize it to fit only our needs, which is usually a better idea. But it would also work catching that. You can see there's a lot of them. Not bound. The numbers just kind of grow indefinitely. We're looking through the registry, but we're looking for something not in the registry. So our software will keep looking. We don't know how big a register is, right? A software registry. Kind of like when something goes very wrong on a Windows machine and you have to hit Control-R and open regedit. We don't know how big that software registry is going to be. The hardware registers, we know exactly how big those are. But anytime we go looking through that, there's no end to it. So we have to handle that thing with no end. Unlike reading a file, there's eventually a bottom. There's a spot where it stops. But you can see there's a lot there. Since we're getting into like JSP, Java server pages, and we'll look at servlets at some point. Servlets are the same, just the server side code that there's no HTML in it, just echoes back, usually the Ajax running in the JavaScript file, and then that updates the page. But maybe we have something wrong. The server is sending the wrong MIME type. What's a good example? We're sending image data and we accidentally listed it as text instead of image data. Things that could happen. Sax exception, that's an XML parser. That's a really nice XML parser. But you can see there's a lot of exceptions already there for us to either use or extend to fit our needs. What all do we have an exception? Scroll down and you see there's only a couple. A couple of methods. Well, really the methods come from up here. Show the stack trace. That's usually what we want to do. Actually print out the message, the error itself, see what happened. There's only a couple methods. And then some constructors to call it. Oh yeah. I was just pause for a second to think if it would be better to look at the other examples, and then out of the corner of my eye, I already deleted all the other examples from my computer. I guess I didn't need to waste 2 seconds thinking there. I'll just create a new Java application for this. And quickly look at some of the syntax for it. Get all this chunk out of the way. Which I guess this is also a good place to point out, on the Java docs, if you use code generation, instead of typing it all manually, Alt insert, and add a property or there's no properties. In some situations, after you add constructors, you'll get methods to add. You'll get options to just add generic methods and get a little dialog box fill in. If you do that, the Java docs it'll start the Java docs for you, kind of like we have on the template here. Different ways to type the code. The end result's the same, and then that point I've expressed a few times. A computer is much better at typing than you. So let the computer type as much as possible. Copy, paste, duplicate. We end up duplicating a lot of lines when writing code. I think everybody's aware of that, right? Copy and paste, and it's exactly the same. Then you make like one small change in each line. There's usually keyboard shortcuts to do that quicker. Predictive text. Anytime the computer can type it for you, it's beneficial to have it do so. So what's a good first example? I'll start with just a basic try catch. That one that was on the board earlier. That seems like a good example. So I'm going to ask the user for input. So we'll need a scanner. Java.util. I was going to grab everything from Java.util because before long, or very, very soon, the examples are going to include array list, at least some sort of collection, and other things that might be in Java.util. So set up a scanner. From the keyboards, a new scanner. And our keyboard is the default system input. We'll print out some messages, print out, enter the first number. I'll put the exact same first example I had on the board. Then we just said enter a number, so we don't really know if you give us a whole number or a fractional number or what they're going to give us. So I'll just assume or prepare for a floating point number. Oh, that'll work for this. Double first is keyboard next. Whoops, not next byte. Just whatever they give us next. Which might not be a double, right? We could do next double, but I'm gonna put it the other way, double dot parse, double from all of that. And then the next one's gonna be almost identical, so I'll just copy both of those lines, paste it in here and say the second number. Make this the second number. And it's still the next thing coming from the keyboard. So quotient is first divided by second. Which isn't really a quotient. Quotient's a whole number. Quotients go with remainders, but that term still fits. Close enough for us here. I guess we can print that out, but y'all probably already guessed I was planning on throwing the error before we get to that print line at the end. Or maybe the first time will work okay. Nothing fancy there. Sort of stuff we were doing the first week or so, right? Just get some basic input, do very simple math with it. all things we've seen before. If we run it, we need a couple numbers. So like 3 and 4 are a couple numbers. We get a result. So all right, software works. That's good. Go ahead and release the software. And then some user goes and runs it. 3 and 0. And here we kind of get a problem. That's technically the correct answer. But that's not the answer we want, right? We want a better answer than that. Infinity means more. So that's not really the answer. And really that's only the answer if we take the limit of 3 divided by 4. Or 3 divided by 0, sorry. 4 was the first one. So that's actually the answer to a different question. It's the best answer we can give for it, but it's actually the answer to a different question, not ours. So that's where our first look at this. So we'll set up a try block. We'll try to do some code, then catch any errors that happen. And we have to be explicit. So exception E. And I'll just print out, can't divide that. Move that stuff up there. So hopefully we get a couple numbers that we can divide, or we'll do something else. So those valid numbers, 3 and 4, still work fine, just like it did before. Anybody want to take a guess? Is this going to work or not? Because it didn't really throw an exception, did it? That's such a common one, it was already built in. So it still kind of does the same thing. But, oh, I meant to leave that list open. Exception. Whoops. If we look through the list here, does anybody see anything that seems like it would work or fit better with division by 0 than just the general exception? Kind of a long list, hard to look at, right? We don't know what we probably normally do. Division by 0, exception, Java. So it is actually an arithmetic exception. It gives us an answer, but that's such a common one, it's not built into Java anymore. We would need to make that explicitly. It used to be in Java, like a long time ago. I think only up to like Java 4 or maybe 5. And we're on 8 now, so quite a while ago. Most of y'all were probably very, very young whenever that exception was still in the language. But maybe we want to throw that exception explicitly. Oh, maybe that won't make a good example. we could make a class that extends that. We haven't really looked at nested classes out. If we want to put more than one class in the same file, I'll put it down here. Like, okay, instead of making another class, another file, I'm just going to put it right here because it's the only place it's ever going to be used. It's only going to be used in the other stuff in this file. This is going to throw a problem here in a second. Zero exception. Extends exception. We can make a class, but it's underlying saying there's a message. Look at that message. This class should be in a file that has the same name as it, not in a file called Java application 22.java. So if that's the only place it's going to be used, we can nest the classes. Maybe the only class that's ever going to need that other class is this one. So we can nest it inside of there. And that handled that error. So we're never going to need it anywhere else. In general, across the board in software development and all of your languages, that's good format. A couple of our languages do actually enforce it. The bare minimum is when we had that class down here, you do not want to put your class definition into the same file that instantiates that definition. You want to have those separate. Otherwise, you can never use it without it running automatically. You permanently lock them together. So it's always a bad idea to do that. And Java enforces it. But we can do nested classes. So if this is the only place it would ever be used, we can just nest it inside of here. Really as a private class. So it's like our other private data fields. It's not accessible from outside. So we're extending exception. And then we add some stuff in there. This probably isn't a good example because we'd have to do a bunch of stuff to grow the exception again. Need to check our numbers and stuff. So we'll come back and extend another exception, but that syntax we've seen before, right? We make a subclass and then define it particular to our needs. And it seemed like a good place to talk about that. And we'll talk about better than the divide by zero exception, because that's handled in Java with the best answer we have mathematically. And that's going to trump anything we do. But there's other errors along the way. I just wanted to start with that because that's a great example to look at. Or a great one to understand, because most people by this point know why that doesn't work. But it's so common, they already handled it in the language itself, and then we have to go back and rewrite the code to throw that exception if we want to customize it. Another thing we could do instead of division, let's make an array list of doubles. I'll just call it list. It's a new array list. So instead of grabbing those and doing math with them, let's just add them to that list. List.add. Oops. Sometimes predictive text gets to be problematic. I think y'all know about that. I thought it was doing something else there. Whoops. So at the beginning here, I'll type list.add and hit escape so it doesn't try to do things. Doesn't try to automatically do things. So let's just add them to a list. All right, there we go. We got a few numbers in the list. Need to print those out.
I'll do it here. For int I equals 0, I is less than 3, I plus plus. And just print out whatever's in that list. This dot get I. That one's going to be a bit of a problem, right? I'll erase this earlier. The compiler doesn't notice anything. There's no little red marks on the page. IDE is compiled constantly, so we don't have to wait for it to see any error messages. We would already see them if there was any. So we go ahead and run it. It's going to ask for some numbers. I'll just add 3 and 4 to the list. But this is what happens. We had an index out of bounds exception. So that's something we can watch for and catch here. Put this in the try catch log, and we'll catch index out of bounds exception. I'll call it IOB. That sounds like a good name. IOB.print stack trace. I'll just go ahead and do that thing that I don't like, because we can see what happens if we don't do that. It tells us what the message is and prints the stack trace. And I'll copy and paste this up here. Oh, it didn't go. And I'll throw in a finally, because we haven't looked at that syntax yet. Okay, all done. So no matter what happens, we'll get this. This is what we're going to try to do. We'll try to start printing out the stuff in that list. But this one was intentionally set up to throw that message, so because that's what we're looking at tonight. There's our basic syntax. And that increasing generality. We start with the, like at the bottom of the inheritance tree, most detailed one. Obviously, index out of bounds exception is far more detailed than an exception. You know exactly what's going wrong there. Then we work down to the most general one, which is the sort of catch-all scenario, and then the finally block for whatever we want, what's going to run no matter what. Because that's always your goal. That printing the stack trace is going to kind of stop our program. Stop the program, print out a message. That's what textbooks always do, because they're restricted for page size, right? They're restricted, just have to introduce the concept. Tutorials the same way, they're restricted on time, so they can spend a lot of time, but this one just does the same thing that happens if we didn't handle that exception. So that's not really exception handling, but if we enter a couple numbers, the main thing I wanted to look at is look at where that exception happens. We don't get the finally block. Finally ran before the stack trace. So it's not running sequentially. That's the main point I want to look at there. It will go ahead and run, and then the error goes at the end. Let me move this back here real quick and show without that. I'll move that up there, and then I'll comment out that handle so we can compare it with and without. So here's the same thing without it. We tried to run that loop.
And then we print out that we're done. 3 and 4. And you'll notice it never got to that print statement. So whenever it hit the exception, it just stopped altogether. Down at the bottom, it just says build failed. So we never got our print statement that way. So the program does keep running. I can just undo it. That's probably quicker. So it tries to print stuff out. It prints as far as it can. Told it to print 3 numbers and then only gave it 2. And then it ran the finally part. And then it threw that exception stuff. And then it did the catch stuff. What else we got here? IOB dot. This is the get stack trace, get message. IOB dot. Get cause. Those are the main 3. We'll put some labels so we can tell what's what. Message. Then has a couple line breaks. And cause. Then has out a couple line breaks and stack trace. That way we can tell what's what here. Looks like it didn't really do much, did it? Don't see anything in the message. Don't see anything in the cause. And that's because we have to fill those in. If we expect that to happen, we need to kind of fill in what's going wrong. The stack trace is going to happen all the time because the computer runs our code as a stack. So the stack's there. You can always go back down the stack. And you'll notice that it's kind of showing up in the strange places. So it ran that catch block. That's why we have the system out, the regular code that happened there. Then we have the finally block. And then we have the stack trace. So for cause and message and all that other stuff that might be there, you'll want to set that up initially, but notice that order in which it runs. Any regular Java code in that catch block will run. And then we get the other stuff. Then the finally block, and then the stack trace or other issues will print out. So it jumps a little out of order. While you're studying, you might want to intentionally mess up that order to see that a couple times. So I'm going to change this up a little bit more. Because doing all this in our main method, that's kind of bad form, right? That code's not very modularized. It's not in a good form to work with. So we should probably have some methods. In main. So we'd probably have like a public or a private method that returns an array list of doubles called fill list. And we'll create an array list. Actually, I'm gonna do this a little bit different. I'm gonna something we would do more often is we want to work with regular arrays. But their arrays are non-dynamic. We have to know ahead of time how big they're gonna be. So a common thing to do is set up a method that will return an array of doubles. And internal to that, we have a local array list. So that way we're only being wasteful with our memory in that local spot. So it's quickly made and deleted when we finish this method. And then the method will convert that list into a regular array so that the rest of our code runs faster. That's a fairly common thing to see, so might as well do that here. List is a new array list. And really it's gonna do the stuff from up here. I'll take the scanner and move it up here to a private data field. That way we can use it anywhere in the code, no have to recreate new scanners and things like that. Does what I just did confuse anybody moving that up there? Because all last week we were looking at making public classes, making our own objects. We haven't done this in the main, but we can set up our private data fields here as well. And because setting it up here gives it global scope. So then we can use it in the other method and do this stuff in the method instead of retyping that. And there's a couple to return this, we still have to create an array and say how big it is. But the thing is, we know it's going to have everything from the list, so we know how big it is now. So we'll create an array of doubles. Let's call it ARR, is a new array of doubles, but on the size, I know it's going to be list.size. So the dynamic capabilities of the array list are just a temporary local variable that we quickly fill up, get the size from it, and then we can convert everything over. Either as a for loop, or there's some built-in methods to do that. And that is going to be, I think, array.tour. The one I started to type, I suddenly realized is definitely a C# method. Nope, it's not in there. Arrays.asList. Is it from the list? Sorry, I suddenly remembered C# instead of Java. Oh, yeah, it's in the list to array. But that gives us a bit of a problem because it doesn't seem to know that we have doubles in there. Will that fix it? Nope. So it gets confused and doesn't know this. The reason I can't remember it is because there's a lot of casting that has to be done. So I always just do a simple for loop.
For D in list, ARR. Oh, wait, can't do that. If I is 0, I is less than list dot size. I plus let's just walk through it, and then each index is just going to be the next thing in the list. List dot get. All right. I always just do it that way because there's a lot of casting that can get a little confusing at first at times, and languages build together. All of our languages do it in drastically different manners. Then we have to cast stuff and do all sorts of other little tricks. So it's a whole lot easier just to set up the array and then walk through it in a for loop. But now we have those dynamic capabilities. It doesn't matter how big our list is, right? We can keep adding things, probably put a selection structure in here. Let's say string input equals done. First blank string. And while input does not equal done, print out a prompt and then enter the next number. Or done. And finished. Let's see if I can make that fit on the screen. Okay, yeah, there we go. Fits nicely on the screen. So sort of whatever's that, what's there should look familiar, right? Hopefully that doesn't confuse anybody. That's sort of the sort of error handling you would have seen in your SDEV 120 class when you got to selection structures and loops. Sentinel values. Enter the next number or type the word done. Which will throw an error. Okay, yeah. And then we can convert it to this, which is going to throw an error. So we'll need to be ready for that error. We won't even get that far. So the first thing we want to do in the main method is then call that method. We know we're getting an array of doubles back. I'll just call it dubs, is that fill list method. Oh, I'll just do this, public static double. I just switched that to static, so the quick way to avoid that error. So we'll fill that up and somehow then do something with it. For E in dubs, this time it'll work. Print out, whoops. If I can get my syntax correctly. There we go. Print out whatever it is, plus a comma. That'll work. It's not going to get that far anyway before it hits an error message. Hopefully that makes sense. And the general idea here is going to look fairly straightforward. Oh, that static is gonna cause more trouble than it's worth. So let's do this. Oh, can't do this. So we've seen that before. I just created all this stuff gets out of the way. Just quickly created an instance of the class we're working in so that we can avoid all that static, non-static stuff. Because we want to minimize how much is static. If we start making things static, it'll cascade through and then everything's static. And that leads to very, very poor resource usage. So we always want to minimize the amount of static things and don't make it static unless we absolutely have to. The textbook showed that in a lot of early examples because they hadn't talked about objects. So when they wrote the chapter on methods, they hadn't covered anything about how to do the other ones. But you all have seen that stuff. We're still in the same spot though. It's not going to get that far without knowing the error. What's underlined now? Oh, don't need that code anyway. It's not going to run that far before it throws an error. So printing out the previous stack trace, and we're only going to go for about 5 more minutes here. We're going to finish this example. We're going to look at this error, and then we're going to look at the throw syntax, and that'll be it for tonight. That's why we're not taking a break, because at this point it would be 5 minutes after the break. So enter the next number, or done when finished. Let's enter it 3, 4, 7, and then we're done. And we got this error. Number format exception. Somebody want to tell me where that? Do you see where that's coming from? If we look at the code that did run, we see our prompt. So we got this line. And then next thing it does is it tries to grab the next thing from the keyboard and add it to our list. And along the way, it's going to try to parse it into a double. But if we enter a word, the next thing on the keyboard is not a number. So we might want, we could throw in a try catch block there for that exception that we know is going to happen. And that's how you want to build these up. When you see the errors while debugging your program, that's where you need to work in exception handling, because that's the sort of thing that should be anticipated. It's probably really small on the screen, but I'm trying to point to that word anticipated that I wrote on the board earlier. Anything that you can anticipate happening, well, we can anticipate a number format exception happening. I'm going to copy that, paste that in as an NFE. Sounds like a good name for it. And in this case, I'm just going to move on. Because exception handling in this case is just don't print the error message. When we see that thing that's wrong, then that means the user probably entered the word done, which is our sentinel value, which means we need to leave the loop. So there's no handling to do. So sometimes it'll just look like that. And that's one you'll never see in the tutorial or textbook. But when you're writing big pieces of software, you will see that a lot in your own code. Because we knew that was gonna happen. We don't, it's like, okay, yeah, that's fine. Just move on to whatever's next. So now we should get a little further. 3, 4, 5, done. Uh-oh. Oh, I guess there is something we could do. When that happens, we need to set input value. Or that probably should have been done anyway. I'm gonna leave that in there. Just move on. That was a line I probably should have put up here somewhere anyway. Well, I'll put it here. Input equals keyboard.next. Or manually type the word done, because this could cause a problem. Let me stop that previous run and run this, and we're back to that situation of can we really trust our users to enter the word done just because we asked them to? Maybe somebody tries to type exit, but now it's just stuck. It can't do anything. So maybe a better thing to do here, if the user enters that, we can manually put that sentinel value in here. Then we know it's typed correctly and everything. You don't have to worry about the case or case sensitivity or any of those other issues. We know we will eventually hit that sentinel value. 3, 4, 5, done. And it jumps back to the caller and does the printout. Or we can anticipate the users not doing what we asked them to do in the prompt. So whatever the user types in, if it's not a number, we'll put the actual sentinel value there ourselves, exit the loop, and complete the software gracefully. That's the sort of idea of what's happening in with exception handling. The very last thing that throws can be fairly easy. I'm going to make another method down here. I'll mark the end of that so I don't get lost in the code. And build a list. And make another public method. Maybe this one returns, it'll return a double. Too big. And we'll take in we'll take in that list, a list of doubles. I'll just call it dub here too. And well, to make this quick, I'm just going to intentionally print out something that's too big. Print out dub index dub.length plus 3. That can be avoided. Change what I was originally going to do and just jump right to the error message, and we'll wrap up for this evening. Fixing this one. So an error message we've seen. Oh, I have to call that. Stop. Then up here, after we do all of this earlier stuff, we can say p dot too big, and then pass in that list. Always seems weird writing code that is intentionally going to throw an error. I guess it doesn't really matter what's here. 3, 4, 5, done.
And I think that's the one we saw earlier, right? Array index out of bounds. Like, oh, we saw that earlier. So we could do the same thing, put a try catch block here, try to do this, catch an array index out of bounds, but if I uncomment this stuff, I'll do this here. What do I want to do? I think so. That might not have been where I wanted to paste that. We get that same handling that happened earlier with the thing there. But if that wasn't in our block, notice we didn't get to that error handling that happened earlier. This is where the keyword throws comes in. Throws exception, or more specifically, we know which one it might throw, so we'd probably be better off to throw this one. We'll look at the difference of it. Whoops. Save that. And when we run this, oh, why is there an error? So it throws it back up here. So when we call that, we have to, when we have the keyword throws, we have to put that in the try catch block. So we can't just call this method automatically because we already anticipated what errors might happen. So we can only call that from where it was a moment ago. I think this will work. Or, whoops. Now where I thought my cursor was. Let me put my cursor down here. 4, 5, done. And it caught the correct error message. So let me change up these messages. Print out index out of bounds. We already saw how to print a stack trace. That way we can tell which one we're in. Print out index out of bounds. Oh, wait, this is exception. Run that, do kind of the same thing, 3, 4, 5. Done. And it caught the index out of bounds exception. A couple quick changes. I'm going to cut this and paste that first. And you can see what the error message there says. Exception index out of bounds has already been caught. We put the parent one first, so that's obviously going to catch anything that its child exception could catch. So the order matters. And when we actually threw that message, we got array index out of bounds, not just index out of bounds. AOB. And before I put that other curly brace on there, Anybody have a guess on which one's the parent and which one's the child? The name kind of says it all, right? Mhm. If y'all didn't hear him on the video, he said index out of bounds is the parent. Oh, we have to have something there. That's out, array index, all that stuff. Oh, whoops. Too many curly braces. There we go. Which, yeah, the name there kind of says it all because of the Java naming conventions. Child classes add more details, so the one with the longer name, more details in the name indicates that's the child. So we're gonna do this way, 3, 4, 5. Exit. We get that array index out of it. That's the one that caught it all. So you'll notice the parent ones will catch the child exceptions that should have gone to the child class. So if you miss some and you just want to pay attention to the order, but as a result of that, we can't get by with just the general exception every time. So probably for most of our class examples, we are just going to do the exception every time to save time, because we're very restricted on time. Time's a precious commodity, right? This time of the semester, I like to make sure there's plenty of it. We're in a 16-week class, so we can stretch ours out a little. Your 8-week classes can't really stretch out so much. Probably got some midterms due this week or next week, or projects that you need to work on, all sorts of stuff, right? Time should probably use some time. So that's pretty much what I wanted to cover this evening. The general idea of exception handling, but still that we haven't really handled any exceptions. We just looked the syntax. That's the word. The syntax of exception handling. We'll come back and look at actually handling an exception, but it is a very large process to squeeze into a classroom, and it's unique to every situation. We do not have a general one size fits all that goes inside of that catch block. That is very particular to what your program is doing. And we can extend any of these and make our own very unique detailed one that perfectly fits our software as well. Definitely something you want to work around with. Exception handling is one of the things that is kind of an art form in and of itself. And some people are more talented than others, and for everybody, it takes some practice. So something you want to work with, but it definitely doesn't fit in the time constraints for classroom. Does anybody have any questions about that syntax stuff before we wrap up for this evening? Thank you for putting that in the chat room earlier, Mark. He wrote down what that word I couldn't remember stood for. Okay, I assume 5 seconds of silence means no questions. So that'll be it for this evening. As always, I'll be here till 8:50, ready to jump back on a Zoom call in a split second. If anybody has any questions, let me know. Your calendar should have this time slot blocked off to learn IT. So please spend our time productively learning something from IT or other classes. I do teach more than this class. If you have questions about other stuff, whatever is more pressing on your schedule, feel free to send those to me as well. I teach more than this IT class. My degrees are actually as a mathematician. I have also been a English and accounting tutor for 8 years now, or almost 8 years. So I can help with lots and lots of subjects, not just Java. I'm here ready to answer questions if you have any. If everybody leaves, and I'm the last person on campus, I'll probably drive back to Clarksville. But otherwise, send me a text message. And we can jump back on a Zoom call in a split second. Or Ivy Learn messages. Those are the quickest ways to get a hold of me. Otherwise, you all have a good weekend, and I will see you on Tuesday.